more than 5,000 equipment. About the product profiles, we make induction melting furnaces and holding furnaces for basically steel melting as well as foundries. We make refining equipment, metal refining converters for stainless steel application as well as decarburization. And we make lead refining furnaces for dephosphorylation as well as desulfurization. We also make continuous casting machines which are required for direct charging in the rolling mills and suitable for direct charging in the rolling mills. Then we are also making air pollution control equipment specifically for induction furnaces, transformers, substation transformers as well as furnace transformers and various productivity improvement equipment. We have complete manufacturing, equipment manufacturing facility at Ahmedabad, and we have a commercial steel plant 0.6 million ton capacity at Kutch in Gujarat, where we are making 0.4 million tons of TMT as well as 0.2 million tons of ductile iron pipe. This facility has got a filter plant, blast furnaces, then sponge iron plant, then induction furnaces, rolling mill, cut and bend, then epoxy coating. So Electrotherm has got a unique blend of not only manufacturing equipment but also actually as a user of the same equipment. So we are actually very passionate about induction furnaces and steel making through it and making quality steel making through induction furnaces. So as we all know that steel making routes, there are primarily two routes. One is through BF, then there is a refining and then there is a continuous casting machine. And there are electrical routes in which there is electric arc furnace as well as induction furnace. You can melt, scrap and sponge in any combinations in both the equipments. Then you have to refine it in the lead refining furnace and you can send it to the continuous casting machine. As explained by my colleague in the session 1, induction furnaces, integrated induction furnace steel plant will have to have lead refining furnaces for making quality steels. Now, steel for long product has been predominantly catered by induction furnaces. Induction furnaces, why it has been catered by these induction furnaces? Because of the capacities, this micro and mini integrated steel plants can be put up in various pockets, and that's why induction furnaces crept up, and they were easily installable at places where the scrap or the sponge was available. And it has much lower capex. If you see a complete cost of putting up a 1 million ton plant for integrated induction steel through induction furnace route, consisting of beneficiation, pelletization, DRI power plant as well as rolling mill, it is $0.35 billion as compared to $1 billion through a primary route. And secondly, it doesn't have any dependency on any of the import items like coking coal, or in recent context, even the graphite electrodes shot up very high. Now it has cooled down, the prices have come down, but it is not dependent upon a lot of import materials. So secondly, also substantially short project gestation period. These plants can be put up in just 1.5 years time from date of inception, and there is a flexibility to use DRI as well as scrap in almost any ratio. And also the capacity utilization is, there is a flexibility to use the various capacity utilization. If you compare, almost 30% of scrap is being melted in the induction furnaces, so it doesn't require any mining so there is a comparatively low reduced air and water pollution. Also, if you compare total energy consumption, if you compare to any electrical route which consumes electrical as well as chemical energy, induction furnaces use only the electrical energy. So if you see, the total energy consumption is lower, and there is absolutely no issues of meeting any quality norms set by BIS standard and international norms for rebars, TMT bars, and any other long products by employing all the necessary machineries like refining equipments. If you see the total installed capacity in India, it was 145 million tons. Out of this, 107 million ton was the production of crude steel in India in 2018-19. Out of this, almost 30 million tons was produced through induction furnaces. So induction furnaces play a key role, and if innovation happens in this, a lot of savings could be done. Electrotherm at different point of time had done a lot of innovation, has upgraded the sizes of the equipment and brought in new technologies in the induction technology. And in 1999, we commissioned the first 20-ton furnace, and in 2009, we commissioned the first 40-ton furnace. Now we are going to set up a first 60-ton furnace in India, and we are ready with designs for 80 tons. So the capacity has also augmented. With this capacity, a lot of innovation has also been driven from a single converter to double converter, from double converter to 4 converters, then intervention by digital technology. We brought in a new technology, absolutely changed the analog platform to digital platform, and we brought in digital inverter fiber optic control, which was a game changer for the complete industry. Advantage of Electrotherm was that we had our own steel plant, and any technology we wanted to bring, we could first actually test it in our own steel plant. So it bring in any technology which was brought to the market was actually tried, tested in our own works. Now, what this GTI 490 is a new technology with several new advanced features. This is embedded digital control technology. The complete control philosophy has changed from analog to digital. With digital information intervention, a lot of savings has been done. This is high efficient induction furnaces, and they have been path breaking. We could achieve and continuously sustain 490 units with 10% sponge in rest scrap. This was 40 to 50 units less than existing performing furnaces. So almost 30 million tons is being produced with induction furnace route, and if this kind of a contribution comes in, it's a huge saving for the country. Automatic control, this also has a lot of inbuilt features like melt evaluator, which continuously evaluates the amount of energy being consumed and keeps a caution on the amount of energy left. So internal self-diagnostic, which actually improves the uptime of the equipment. Then global accessible equipment through secured Ethernet connectivity. You can access this through anywhere, and in fact, this can be diagnosed from remote location. We have a complete setup in our corporate office at Ahmedabad, where we can diagnose the equipments remotely. Energy monitoring and data logging system. This is for good MIS. Some of the screenshots. This is a 40-ton furnace which is being operated with all the digital platform. You get all information. There is a self-fault diagnostic feature. In this feature, if you see, this shows the fuel blown. It will show the location where it is blown, and then it will circle out that this is the faulty. So, this improves the uptime of the equipment. Same way for different, like this converter water failure, it will show the location and it will circle out the place, and it will show which part to be changed. So this actually has been improving the uptime of the equipment, reducing substantially the power, the cost of consumption of electricity in the furnace itself. This melt cycle evaluator, for any combination of scrap, you have set parameters for power consumption. On the right hand side, it is showing the actual kilowatt consumed, and on the left hand side, it is showing what is left for that particular combination. So it keeps a check on the complete energy consumption for every heat. You have a data for that, and you can analyze and you can correct. Various MIS reports could be generated. Then various other process developments along with the induction furnaces. One is dynamic load management programmable. You have various loads in the steel melt shop which has their own connected load capacity. Now you can reduce the overall load, and you can this dynamic load management system actually drives whatever available power and supplies it to the induction furnace, and it can utilize whatever extra load is available for generating the extra production. So this is also one good tool. Then we have power optimizer. Induction furnaces are basically resonant circuits in which there is inductor as well as coil. Now inductor is the coil which is continuously on a variable mode, and it changes with the lining and various conditions of scrap. So we have power optimizer in which actually operates the capacitors and tune it to close to the resonance frequency, and we have been able to save between 10 to 20 units per ton through these power optimizers. Then another very important change was direct rolling or hot charging of billets, converting the billets to a rolled product without intermediate reheating arrangement, thereby avoiding this criminal waste of energy. In a normal conventional way, induction furnaces do melting, then there's a continuous casting, the billet is then cooled and then reheated in the reheating furnace and then sent to the rolling mill. When the billet is cooled, you are losing about 0.8 gigajoules per ton of the energy. Now, reheating the billet in the furnace requires almost 1.2 gigajoules per ton of energy. India is producing almost 32 million tons through induction furnace route. So even if 25% of the steel is produced through direct rolling, then about 10 million gigajoules energy can be saved annually. This is huge. So for this direct rolling, the link was the casters. Conventional casters operate with a speed of 1.5 to 2.5 meters per minute. For direct rolling for a 4-meter long cut, the time required is about 120 seconds. Speed of the conveyor can be varied, as per our convenience from 4 to 15 meters per second. So if the distance between the cutting table to the rolling mill is about 100 meters, it can be covered in just 20 seconds or even lesser time. So thus the time required from cutting table to rolling mill actually has to soak the billet. So the important parameters to obtain 100% direct rolling are optimum secondary cooling to get higher temperatures at the cutting table and higher casting speed to allow lowest temperature drop in the initial stage. So Electrotherm developed high-speed casters which offer a speed of 3.5 meters per minute on 4x7 caster and 5.5 meters per minute on a bullet caster. So in concluding remarks, India is definitely going to see a lot of demand in the steel. Through the various initiatives taken by the government, we feel that a lot of growth is going to come into the infrastructure sector, in which induction furnace, along with the refining equipment, can play a very, very important role. Over the last couple of decades, induction furnace steel making has become one of the most important contributor to this total steel industry in India. So it is in need of time to develop efficient technologies, and DTI 490 is developed with digital technology where you can get as low as 490 units on 90% scrap and 10% sponge. So this is almost 50 to 60 units less than any previous technology which was available. Load management system can be used for all induction furnace based plants, wherein you can reduce your overall demand, and direct rolling plays an important role in the energy saving. Elimination of the reheating furnace saves huge energy and carbon emission to the environment, and enhance profitability also of the steel plants. High-speed casters are definitely useful for obtaining the full advantage of this direct rolling. So Electrotherm has been a pioneer for this route of steel making through induction furnace, and we have made a good footmark in the global world. We have supplied in more than 58 countries, and we have supplied more than 550 equipments. Induction furnaces technology is being sold to many countries. Now it is being adopted, and several turnkey projects have been done in countries like Turkey, Iran, Iraq, Saudi Arabia, Pakistan, Bangladesh, Nigeria, Algeria, and various other countries. Thank you very much.
Thank you. Thank you, Mr. Kavi. Now I will request Mr.